I will try to not talk too fast. So, sorry about that. I had everything prepared on my other Chromebook, but it has HDMI only and couldn't connect it. So I just had to transfer everything last minute to this machine. So we'll see how this goes, because I haven't tested anything on here. So I'm talking about JS-Git. I took Git, which is awesome, and JavaScript, which is awesome, and decided to combine them. I had this idea over a year ago. I wanted a way to do programming on consumer devices. And by consumer device, I mean Android tablets, Chromebooks, iPads, phones, devices that have lockdown operating systems where you have no command line, you can't install arbitrary third-party apps, you're in this lockdown environment. And you may ask, why in the world would you ever want to program on one of those? So the pink Chromebook I was going to use, well, coral, it's not actually pink. I can go, in the United States, I can go to Walmart and buy a laptop brand new for $300. And this has the latest Intel CPU, it has a solid state drive, it has free T-Mobile for life, 3G internet, for $300. It's actually a very nice laptop, it's quite fast. But it has Chrome OS, which means you can't run Windows software, you can't run Mac software, you can't even run Linux software unless you root it and put Ubuntu in a CH. Too far? Okay. Oh, that's a good idea. Is this better? And this is the Chromebook Pixel. This one's quite pricey. It's Google's version of the MacBook Pro. And I'm going to do everything on here. This is not in dev mode. There is no Ubuntu on here. If I try to go to the shell, it's not there. So this is a lockdown consumer device. I don't have Node at all, which will be fun because I was going to use Node for my demo. But I can't. So about a year ago, I started a fundraiser on Kickstarter. I said, I'm going to implement Git in JavaScript because the main thing missing from these platforms is a way to download code and upload code and share it with professionals. I want to get more kids into programming. Kids have tablets, kids have Chromebooks, but they can't program on them. All they can do is surf the web and watch YouTube and waste their time. But if I gave them a way to really do things, then these would be useful devices. So, well, okay, it's loading. Internet's working mostly. So this was my Kickstarter. I got $20,000 and lived on that for about 3 or 4 months until I was completely out of money. So then another one on Bounty Source. And this fundraiser didn't do so well, but Mozilla last second saved me and donated all the money. And I lived between these two Kickstarters, let's see, what's this? $34,000. So that was my year's salary last year. It's not a lot of money for a developer in the US, by the way. But I wanted to do this. It was very exciting. And while I didn't implement all of Git, I made a lot of progress. So I'm going to show you what I got done. I have no slides, but I have lots and lots of live demos on a machine I haven't tested. So this could go really well or not. So this application is what I wrote this year, just after New Year's. It's called T-Edit. And what this is this is a Chrome app. So it runs on Chromebooks, runs offline, and it lets you edit Git repositories directly. These files that I'm browsing here, so this T-Edit app here, this is the T-Edit app on GitHub. So as I open these folders, it's making REST requests to GitHub and downloading files, downloading trees, and whatnot. And this filters here, this is a submodule. And I can just browse this as if it was a local folder. So I don't have Node and NPM in this environment, but I have submodules. So here's all my dependencies. And you'll see, among other things, here's JS-Git and JS-GitHub, which is what I'm actually using to live mount the GitHub repo. And this works really well when you have good, fast internet. And I've been using this for all of my work for the last about 3 or 4 months. I'm doing consulting work, and I'm using JS-Git and JS-GitHub to do my real consulting work, which is kind of crazy on a Chromebook. Now, 2 days ago, as I was leaving, GitHub accidentally broke this. They changed something in their validator, it was being too aggressive, and I couldn't write any changes back to GitHub anymore. And I'm giving a talk today. Luckily, they fixed it last night for me, so this works again. But I panicked the whole 2 days I was traveling here. So I wrote a couple of the libraries. One of them is a Node library, which I can't demo because this machine doesn't have Node. And I'll get later into what that does. And the other, and this is a really cool one, I made it so that if you have a bear repository, if you do a git clone -- bear, that gives you just the data. So you got an objects folder, you got packed ref folder, all these fun things in here. And so tedit can now mount those. So where did I put that? In here. All right, so Conquest, this is a game I wrote. So you saw, this is what's in that folder. You got a bunch of hashes with a bunch of more deflated hashes. This is not legible code. However, inside of tedit, it's a folder with files. I can see the last commit message. I can hover over everything, see a hash. I can preview the images and whatnot. This works really well. And so this is actually a Chrome packaged app. So there's two ways to actually run your code in tedit. One is I could serve a web server from tedit, because Chrome apps are able to do TCP server, TCP client. You can access the file system directly. Lots of things you can't do in a browser. So while this is all written in HTML and CSS, it's like a native app. And JS-Git allows you to make real dev tools and real applications that just need data. So I'm going to do live export to the downloads folder, and we'll call it Conquest. Okay. All right, so we just dumped that. Now, this is Chrome OS. So now all I got to do is say load unpacked extension. Where did that go? Where did that go? Okay, I don't know where that went. Where did you download to? Conquest, oh, okay. That was the wrong place. There it is, inside my bear repo. So let's go back to Chrome, downloads, talk, Conquest. Okay, sorry about that. So here we go, Chrome packaged app, and I can run the app. And this is an offline app, so I can write games and build the games and run the games all within the limited Chrome OS environment. This was not possible a year ago. This Chromebook Pixel I bought for JS-Git, and I bumped the cord, and last year at Google I/O, Google gave out 3,000 of these things to developers who have no idea what to do with them. You've got a $1,500 paperweight, because all you can do is browse the web. So I made it where you can do actual real development with this. So this is desktop development, so offline apps. So let me show you some other cool stuff. How many of you, let's see a raise of hands, who uses CoffeeScript? Did you know I wrote the first compiler for that back in 2010? That's a long story, I'll talk to you later, but I used to use CoffeeScript. I don't anymore, because I write libraries. Has anybody ever used a ES6 to ES5 transpiler? Yeah? Who likes generators? I love generators. Do you wish you could use generators today? Well, you can, if you're willing to have a compile step. Facebook wrote this awesome library called Regenerator that lets you write your code as ES6 generator code and compiles down to ES5 state machine switch go-to craziness. But it works. It implements the whole spec. Now, I'm on a Chromebook. I don't have Grunt. I don't have Node. I don't have Gulp. I don't have any of that. And I certainly can't npm install Regenerator. So how am I going to use that in this environment? So tedit has a build system. That's a separate library that you can use with any JS-Git project. So let me mount my, where is it? Yeah, I was going to have slides, ended up just not. But this was going to be the slides. So, can you guys see this okay? Is this big enough? All right. So let's cut to the fun part. Here's the app. This is a very simple app. So GenRun is a library I wrote. Lets you use generators to block on promises. So I have a simple synchronous for loop. I'm going to write I to the body. and then I'm going to sleep for 500 milliseconds. I'm going to block my code waiting for something to happen, and then so this is going to count from 0 to 10. And I'm not actually using A+ promises, I'm using what I call continual promises. You don't need a library. Literally, you just return a function that takes a callback, and that's an ultra, ultra lightweight promise. But GenRun supports that. So I return this promise thing, which then calls set timeout, pass it in the callback, and this is sleep. And you can use this with anything. All of the JS-Git public APIs support both node-style callbacks and continuable-style promises. So you can write JS-Git code where you block and wait for, give me this object, give me this tree, give me this list. Like all the I/O you do, you can write synchronous code if you wanted using regenerators. So let's run this, because this is obviously not going to run in Chrome. I haven't enabled any flags on this browser. Stable Chrome does not have generators. So if I run this, it'll be a syntax error because of that star right there. Function star is not ES5 JavaScript. But I wrote somewhere here, I took Regenerator and Browserify and packed it into one massive compiler for tedit, and also added in a compiler that adds AMD wrapping to all of your modules. Who likes node-style synchronous require? Who uses require.js? Who still uses traditional script tags? I do all three. Mostly the node and the script. So here's my app. So I pull in Regenerator runtime, that's just a normal script tag, and then Bootstrap, which is a 200-line loader that is an AMD style loader. So all of my code has to be written in AMD style. But as you saw, oh, this is getting crowded. This is not AMD style. Run equals require gen run. There's no wrapper. How is this going to work? So again, we have the compile step. And here's the secret sauce. In tedit, you have rules, which are executable files. Git supports the executable bit, so it's preserved. You say, I'm going to use the compiler program, which is this one we just saw that has Regenerator and AMD. And I'm going to input this folder, app source, and I'm going to create a folder source on the fly. So I'm just going to spawn up a web server here, because I can do that. Port 8080. All right. And if I can remember my shortcuts. So here's the source folder. There's my 2 generated JavaScript files. Here's main.js. And as you see, we got this define wrapper here. It's main.js, it depends on genrun. And then there's the actual body. And then we have this crazy while one context switch statement. This is the output of Regenerator. So it compiled my generator code to ES5 code. So that's cool. So what did I call that? App HTML? Okay. All right. I fixed this bug on the other machine. Well, that's unfortunate. I think this is a bug in Chrome. The problem with using the latest technology is it's not tested yet. But if this worked, it would count from 0 to 10 with a 500 millisecond delay. You can see it on my other machine. It works great. No, this is not cool. All right, it's time to go spelunking. I need this fixed. So I'm using this version of tedit. I know exactly where the bug is. Source, data, pull serve. And this is Carrot. This is another Chrome app that lets you edit files on the disk. I can't use tedit because tedit only edits Git repos. And somewhere down here, right there, that's the one. That's wrong. Who knows typed arrays? What happens when you take a typed array and feed it to another typed array? It makes a copy of the bytes. And somehow this fixes the bug. Because if I don't copy the bytes, it gets the wrong bytes, and you see that Git header in the way. All right. Now, let's restart tedit. Restart my web server. Please work. And we get to debug some more. Isn't this awesome? Oh, I typoed U in it. Great. Unsigned int. There we go. Reload. All right. Server. Yeah. I want this demo to work. There we go. Look at that. That was too much. All right. Next demo. Someone come up here, grab a joystick. You want to, Greg? You're close. All right, don't plug it in yet. Just stand back here. This actually doesn't have a whole lot to do with JS-Git. I'm just showing you how to make web apps.
What am I doing?
I'll tell you in a second. All right, so this counter, that's boring. I'm going to make a game that uses Pixie.js. This is a WebGL 2D graphics library. I've got some sprites. You can see them here. And a really, really simple game using that. And we're just going to spawn up another web server. Wow, that's too big. We'll do port 8081. All right, so when I tell you, plug that in, but not yet. So what I'm showing here is that I'm in a Chromebook, but I'm not limited. I can do crazy things. If I had time, I have some Arduinos back there. I could plug into the Chromebook over USB drivers in Chrome. I can implement the Fermata protocol and control the Arduino from a Chrome app written in tedit, all on this supposedly restricted consumer environment. But I ran out of time, so we get a joystick demo instead because that's a lot easier. All right, so this is my game. So I plug in my joystick, it detects it, and I can move around. So now plug in yours. Okay, there you go. So you see, it auto-detected the USB. Now, if you press down on the right one, you shoot sparks. And you can like control what direction you shoot. By the way, I wrote this game on the plane yesterday, or the day before. Was it yesterday? So, it's not the best game.
It's awesome.
But I'm using WebGL. This is a Logitech gamepad for PC, and doing all of this on a restricted environment. And I wrote the entire thing on a Chromebook, on a plane, in the air, offline. So, people who tell you that Chromebooks only are for browsing, no. Thank you. All right. So, you know I'm not cheating because there's no Linux on this machine. My other one I have Ubuntu as a backup in case I need it. This one I don't. So, this build system in tedit is also how I solved the dependency problem. When you're writing a Node project, and I've done Node since 2009, a long time, how do you grab your dependencies? You npm install, and they're there, and you require, and it's there. How do you do that in a browser? There's, I don't know, 20 different module systems for the browser. There's no consensus at all, and they're all weird. And yes, I made another, so now there's 21. So these two, these .git folders, these are local on my machine. I took a bare clone from that machine, stuck it on a USB stick, and copied it to this machine. And this is a full repo. Like, I can change things. I can take this README, mark it as executable, and I can then make a commit, and it'll be committed locally. And then if I had Git on this machine, I could then go to that bare repo and push to GitHub. Because what I don't have yet in JS-Git is the network protocols and merging. So that's the really interesting things, because then you can do all sorts of data synchronization stuff and use JS-Git in replace of CouchDB or MySQL or whatever. And you can have web apps that sync from a data provider to the browser and store it and work offline. But I still have to implement these protocols, and the hard part, the wall I'm hitting, is a browser only has XHR and WebSockets. And XHR has same origin policy unless the server implements cores. But none of the popular Git providers have implemented cores. GitHub hasn't, Bitbucket hasn't, and I'm talking to them and trying to get them to do it, but they haven't done it yet. So even if I implement the entire protocol, you can't clone from a browser. And that makes me sad. But maybe someday they'll have a change of heart. In the meantime, a Chrome packaged app has full access. I can make an HTTP server. There's no cross-origin issues here. And in Node, obviously, you have full network stack. So it's useful. And then merging is, yeah, I'll have to get that done. But right now I have the database. So let's see. I had notes on the other machine. Right. Let's dive into tedit itself. So I'm editing tedit with tedit. For the first few months, the way that I built tedit was using tedit. It was a self-hosting compiler. And the first day I did that, it was really weird. I couldn't sleep at night. Because if I pushed a new version to the Chrome store that had a bug in the compiler, I would have to manually AMD wrap all these hundreds of files to fix it. And I didn't want to have to do that. So since there's no npm, what I do is I just have a lib folder with all these submodules. And there's a folder here called Chrome app, and this is the actual output, the build target of the Chrome app. And so we have a symlink to ACE. That's just a relative symlink. So you can see it points back to the source min no conflict from ACE upstream. And this is just the Chrome app bootstrap stuff, my AMD loader bootstrap stuff, Chrome app manifest JSON. So that's all just static files. I got my Chrome app icons. Yeah, that's all loading over the Wi-Fi fairly well. And then here's where it gets fun. I have another source rule like you saw before. And this takes my tedit source, the entire tree, wraps it in AMD wrapper, and dumps it here in a source folder. But I also have a source folder. So the way this works is it overlays this on top of the existing folder. So you can have static files and dynamic files all mixed together. And then I have a whole bunch of other rules. So all my dependencies, like Paco, this is a third-party implementation of zlib. Or not zlib, yeah, OpenSSL, TLS. Not OpenSSL, just TLS. No heartbleed bug here because it's JavaScript. You can't have those bugs. They don't exist. So that gives me crypto, which I need for the network protocols and stuff. This is just various libraries. Most of these are mine. CSS parse, this is TJ Hollowaychuk's CSS parser. And what I use that for is, the right pane here is ACE, the Cloud9 editor. And I parse the themes out of that so that when you change the color theme, the tree on the left matches. So that your editor looks pretty. Because that's important. People aren't going to learn to program if your editor's ugly. And yeah, so I just take all my dependencies and I just make lots of rules, lots of symlinks, and this is my build system. I don't have a grunt file, I don't have a make file. I just create files in my Git repo. And then the actual compilers are just in the submodule of common compilers, and I'm using the AMD compiler. So your code that compiles your code lives in the same repo as your code. And I'm in a Chrome app where you can't eval. So I'm doing some clever tricks with inline workers and RPC to actually dynamically build the compiler and then feed it the code and get the output and send it to the, yeah, it's weird. But it all works. And then the actual source code is not that many files. And if the internet wasn't slow, I could build tedit from here. But since this machine has a fresh cache, it's going to take a long time to download all these files from GitHub one by one. But it would work. But on the way here, I panicked because GitHub was broken. So I wrote a Node library that implements all of this compile system in Node. So if you go to, what did I call it? Tedit build. So if you go to GitHub, under my account, go to tedit build. Yeah. And I have instructions for doing a deep recursive clone of tedit app, running this command, and you get a ready-to-go Chrome app. So if I ever break the Chrome store version, I'm not hosed anymore. I have the good version. Yeah, here's the docs. And it works pretty well. trying to think. I wish I had my notes. Oh, I remember what I was going to show you. So this, I haven't actually announced or told anyone, so you guys get to see a surprise. I hope this works. So what good is an editor for making web pages if you can't then host those web pages somewhere? There's no hosting provider that implements the same build system I designed. You could export all your files to a Git repo and then commit those and then push those, but that's really counterintuitive. My goal here is to make programming easy. So I made a project called tedit host. It's still a private repo for now. And what this does is it takes a GitHub repository, just give it a GitHub URL and an OAuth key for that user so you can read from it, and it will serve that as a website directly from GitHub. But it's smart. It has a level DB cache on the node side. It caches everything. It's fast. It works offline. And the way I manage this is with another Git repo, of course. So another private repo. This is what private repos are for storing GitHub OAuth tokens on this massive screen. Don't steal my tokens. I think this one's safe. So here's the config for exploder.creationx.com. So it says who the owner is. So I was thinking maybe doing billing later, starting a company, because I got to fund all this work somehow. This is my GitHub token. Yeah, I may invalidate that in a bit. There's a GitHub URL. It says I want the master branch. The dynamic code is in filters. So this Exploder app has one dynamic file, and that's the app cache manifest. App cache manifest is very painful. You have to update it every time you change anything. So I wrote a build rule that dynamically generates app cache manifest, and it puts a comment, which is the e tag of the file. So anytime you change any file, the app cache automatically updates. So if this file is executable, the site is on. So let me make it not executable. And this is all live, by the way. So commit changes. That's not a good sign. Oh, it's private repo. Okay. So I'm just going to turn off one of my production websites. All right. It's dead. So if we go to exploder.creationx.com, all right, in a non-cached browser, exploder.creationx.com, exploder.creationx.com is disabled. All right, beautiful. Now, let's not do that. Let's turn that back on. Make it executable. Enable Exploder. And so I'm editing GitHub repos live. My running server on my Linux box is monitoring the GitHub repo for changes using JS-GitHub, and on the fly, deploying and turning off websites. So another incognito window, loading. All right, there's the app. And I got multi-touch and fun stuff here. And this app has cache manifest. So if I ever turn the server off again, and you come back, you can still play the game. So you can go to your iPhone, say add to home screen, and this game works offline. So I can deploy games, I can run Chrome apps, what more development do you need? The one thing I haven't done is port Node to Chrome, but I may get there eventually. So this is the current status. Right now I'm doing consulting work to pay the bills because I ran out of money. But when I have money again, I'm going to work on this again and hopefully finish it. So thank you all for watching. This is really fun.
Thank you for being